let's start reviewing for our final with the number sense final review. We're going to go through this review a little bit together and a little bit you guys will do on your own. So make sure that you follow along and write down the ones that we're going to do together and then practice the ones that we don't do on your own. First things first, with number sense, there were two different types of numbers that we learned about way back at the beginning of the semester. We learned about rational numbers and we learned about irrational numbers. On the rational numbers side, there are some examples of whole numbers, which rational numbers includes that category. So numbers like 5 and 0. Notice that 8 halves simplifies to 4, that's a whole number. The square root of 9 is 3, that's a whole number. Then we had integers, which are just positive and negative whole numbers. So including all of these positive values, we threw in negative 3. And then over here we have negative 8 over 4, which simplifies to negative 4. Then rational numbers. Rational numbers are any numbers that can be written as a fraction. So 7/8, for example, or 1/3. This is also a rational number because both 16 and 9 are perfect squares. So the square root of 16 is 4, the square root of 9 is 3. Therefore, this is a fraction 4/3 that, or at least it's equivalent to 4/3. And we have decimals that end. We call them terminating decimals, like 0.97. And there's also decimals that repeat, so 0.21, 21, 21, 21. These are all examples of rational numbers. Irrational numbers, however, are numbers that cannot be simplified underneath radicals. So for example, the square root of 8 is not able to be simplified, or 11, 1.6, fractions that cannot be simplified under radicals, etc., etc. Pi is an irrational number because it represents a decimal that never ends and it never repeats, just like this, 0.303003000. It's similar, it has similar numbers, but it does not ever repeat itself. So this is a non-terminating decimal. It never ends, just like pi. So anything that does not simplify underneath a radical or does not end as a decimal would be considered irrational. Everything else that can be written as a fraction is considered a rational number. So let's go ahead and look at example 1. They want to know which of these would have rational products. Now you just need to select each box, either putting an X or a check mark in the boxes that correspond to having rational products. But just for the purposes of showing you what you're essentially doing, I will show the work as well. So in this first box, for example, we have a row that says 1/7 and we have a column that says 1/7. So if we're looking at the product, remember that product means to multiply. I want to know if 1/7 times 1/7 is a rational number. Again, I don't need you to write this work out. I just need you to know in your head whether or not that will produce a rational. It just so happens that that equals 1/49. And because 1/49 is a fraction, that is a rational number. Any number you can write as a fraction is rational. So yes, this box does contain a rational product. So we'll just go ahead and put an X in that box. Let me find one that does not. How about this one? If we look at this box, we have a row for 1/7 and we have a radical of radical 6th. If I have 1/7 times the square root of 6, I am not able to combine these in any way other than just rewriting them as radical 6 over 7. And since this number, it is a fraction, but it's a fraction that has a square root in it. So if it has a square root in it and you cannot simplify that square root, that means that this is a irrational number. So I am not going to put an X in this box because that is irrational. So this one should be left blank. Be careful. I'll leave that with you. I will just say a couple things. Make sure that you know how to multiply radicals times another radical. So for example, the square root of 6 times the square root of 6. All right, think about that one for a minute, and I want you to tell me if you should or should not select this box as a rational product. If I multiply the square root of 6 times the square root of 6, will I get a rational number or an irrational number? So think about that and answer this question. All right, so the square root of 6 times the square root of 6 would be the square root of 36, and the square root of 36 is 6. So yes, that is a rational number, and you should check this box as well. So make sure you put an X in that box as marking it as a rational number. The only other thing I'll say about this problem, make sure that you pay attention to the radical 4. Notice that radical 4 actually does simplify. It's a perfect square, so take that into consideration when you're multiplying it times all of these other numbers. All right, I will let you fill in the rest. Put check marks or X's in the box that are rational products and leave the ones blank if they are not rational products. On the second example, it's the same numbers, but this time it wants to know about rational sums. So essentially, if I'm adding them together, will I get a rational number or not? I'll just do 1 or 2 examples with you. For this first one, I have 1/7 plus 1/7. Now I'm adding, not multiplying. That's 2/7. Because I can write that as a fraction without any square roots in it, then yes, this is a rational product. So check that one or put an X in that one. How about this one? How about the square root of 6 plus the square root of 6? Should I check this box? Yes or no? So the square root of 6 plus the square root of 6 is 2 square root of 6. And since I cannot simplify that, the square root of 6 does not have anything that is able to be simplified. Because this answer has a radical in it that is not able to be simplified, it is considered irrational. And since it is irrational, I will not check that box. All right, go ahead and check the other ones that will have rational sums. If you add the numbers together, you get a rational number. This is similar to the last couple examples, just with different numbers now. This one, they want to know if this has a rational sum. If I add 5 radical 7 plus 1/7, will that be a rational number or irrational number? So think about whether or not you're able to simplify out that radical 7 from this problem by adding these two together. This is a decimal that ends 12.4 times -11. If I multiply these two numbers, am I going to get a decimal that ends? Is it a decimal that doesn't end? Etc., etc. Think about if that's rational or irrational. The square root of 4 plus 17. Again, I have a radical. Is there any way for me to simplify that radical so that it's no longer underneath a radical? If so, it would be a rational number. If not, irrational. And last but not least, products again. See if you can multiply these together. If you're able to eliminate the square root so that it's not in your problem anymore, again, it would be considered rational. If you're not, then go ahead and check irrational. So let me think about one now. How about this one? The square root of 4 plus 17. I want to know if you should check rational or irrational. So think about that and mark the correct answer. All right, hopefully you've had a minute to think about it. The square root of 4 is equal to 2. So this is just 2 plus 17. And since 2 plus 17 is 19, then yeah, that's a rational number. So you should check the box for rational. Slide 4, again, rational products. Can I multiply these numbers times 7 radical 5 to get a rational product? So if you're going to set these up, you could do them one by one by multiplying them. I'm going to multiply this by 7 radical 5. Multiply this one by 7 radical 5. Multiply this one over here by 7 radical 5. Don't forget to distribute that 7 radical 5 to both terms. Multiply this one by 7 radical 5. So I'm going to do B with you, all right? When I'm multiplying numbers together like this, I multiply their coefficients. So 7 times 7 gives me 49. And then if I multiply 125 times 5, I'm going to get 625. But keep in mind that I want to know if this factors down completely without a radical left over anymore. So we're just going to break it back down into its factorization. So I know that 125 times 5 multiplies to 625 because we just did that. 5 is a prime number, so leave it there. 125 is 5 times 25, and 5 is a prime number. 25 is 5 times 5, and now we have our prime factorization. So if I rewrite this, this is 49 times the square root of 5 times 5 times 5 times 5. And since this is a square root, we're able to take out groups of 2. So we have 49 times that first group of 5s. When you take the square root of that, you get 5. And then that second group of 5s, there's another 5. Again, I don't really care what 49 times 5 is. I just care that I was able to completely simplify the radical, and now there are no more radicals left. So if I did multiply 49 times 5, what I'm going to get is a rational number because the radical is gone. So yes, answer choice B is in fact rational. We should select answer choice B. I'm going to let you look at these other ones. That's not necessarily the only answer. It says to select all numbers that produce a rational number. So any of these other ones that also produce a rational number, you should select as well. So think about all of those, and then go ahead and put your answers down for those. Number 5 is classifying numbers. So it says to just kind of rewrite them in each of these categories. Notice that they may fit into more than one category. Just like at the very beginning, we saw those that flow chart of whole numbers and integers and rational numbers. So these ones kind of go together. And then irrational was just a completely different beast. So I will go ahead and just pick a few to help you classify. So I'm going to help you classify -7. I'm going to help you classify the square root of 25, and I'm going to help you classify the square root of 3. So, -7. -7 is an integer, all right? It's not a whole number, because whole numbers are only the positive numbers. So it is an integer, though. -7 is an integer. And if it's an integer, automatically it's also a rational number, because it can be written as a fraction. So -7 should go in both of those boxes. The square root of 25. Well, think about what the square root of 25 equals. It's actually 5. So, because that is a whole number and it's a positive number, we would put it as a whole number. It's also an integer. All the positive and negative whole numbers are integers, which means it's also rational. I can write that as a fraction. The square root of 3 is a radical similar to this one, except the square root of 3 cannot be simplified like this one could. Therefore, the square root of 3 is the final simplified version, and therefore it is irrational. If I am not able to get rid of the radical altogether, we would consider that to be an irrational number. All right, go ahead and classify those other ones. If you need to go back and remember what irrational versus rational is, go ahead and look back at the beginning of the video, especially for this one. Make sure you're careful on that one. And in fact, let me ask one more actually. Why don't I ask you this? How about you help me classify where we should put, how about this one? Oops, this one. Where should we put 5/11ths? So think about what the classification is for that, and then go ahead and check which box you think, or which term you think we should classify this as. All right, so 5/11ths is a fraction. So because we can write it as a fraction, it should be classified as rational. So put it in that box with the other rational numbers. Number 6, which point on the line is the closest to the square root of 17? All right, well, remember back to the beginning of the school year, we took the time in learning how to rewrite all of the integers on the number line as radicals. So if you think about these integers, 4, 5, 6, 7, 8, I want you to think about what their square root equivalencies are. So for example, 4 is the square root of 16. So if you wanted to just jot that down, that this is the square root of 16. 5 is the square root of 25. 6 is the square root of 36. 7 is the square root of 49. And 8 is the square root of 64. So if we look at all of these numbers and then go back and look at the square root of 17, I'm going to say it's actually pretty close to the square root of 16. And it's actually just a little bit bigger than the square root of 16. So if you look at these numbers, they have 1, 2, 3, 4 numbers that they have written here on the number line. Of these 4 numbers, 7.5, 6.5, 5.25, and 4.12, the one that is closest to the square root of 17 is probably 4.12, since it's just a little bit bigger than 16. So I'm going to go ahead and say 4.12 is the number that's closest to the square root of 17. All right, I want you guys to think about this one. So go ahead and write the square root equivalencies below here, just like we did on the last problem, and then figure out which letters the square root of 20 would be between. So is it between A and B? Is it between B and C? Between C and D? Etc., etc. So go ahead and choose the correct answer. All right, and the last one on this worksheet says to consider the following 3 numbers. 7/5, the square root of 2, 1.414. It says, which of these statements about the numbers is true? Probably the best way to analyze this one would be to put them on a number line. So I will kind of help you out a little bit with that. I know they're all positive, so let's start our number line at 0. And we'll go 1, 2, 3. We'll just go up to 3. Now, in the last couple examples, we talked about the square root equivalencies. So I'm going to let you guys kind of go back over that and make sure that you're clear on what the square root equivalencies are. But I'll go ahead and just kind of fill that in to prompt your thinking. So all of these numbers are equal to the square root of something. Figure out what those somethings are and then plug them into these places. We didn't talk about the fractional equivalencies though. So at the beginning of the semester, we talked about how when we have a fraction over 5, we can say that the whole numbers would be over 5 as well. So for this first one, maybe we have 0 over 5. For the second one, we have 5 over 5. The reason we have 5 over 5 is because if you divide this, 5 divided by 5, you get 1. The next one would be 10 over 5. Again, 10 divided by 5 is 2. The next one would be 15 over 5. Because 15 divided by 5 is 3, so on and so forth, and we could go from here. So again, the reason I chose 5 as the denominator is because this fraction had a 5 in the denominator. So I'm just going to look at 7 over 5 with you guys. 7 over 5 would be somewhere in between 5 over 5 and 10 over 5, and it's a little closer to it's a little closer to 5 over 5. So I'm going to say that 7 over 5 is right about here on the number line, 7 over 5. I'm going to let you guys think about that in terms of these. So think about radical 2. After you fill in these radicals, think about where radical 2 would be on the number line. And then I want you to think about 1.414 and where you think 1.414 would be on the number line, and then decide which ones are greater and which ones are less. If you need to use a calculator to verify your answer, go ahead and do that as well. All right, and that is our review for number sense.